Hello everyone, I'd like to welcome you to this video titled Writing Equations to Represent Situations. And in this video, we are going to take a look at how you write equations and determine whether a number is a solution of an equation. Now, what you'll need to do is get out your Go Math book, your math journal, and a pencil. Calculator would be helpful as well. And turn your Go Math book to page 297. So as you can see at the top of page 297, there's some things that we want to go over at the beginning so we understand what we're dealing with here. So it's saying determining whether values are solutions. So first of all, we talk about writing equations. We need to think about what an equation is. So we can see at the top here, an equation is a mathematical statement that two expressions are equal. Okay, so think of an equation as a balancing scale where one part of the scale must equal the other part in order for it to balance. That's just like an equation. So an equation may or may not contain variables. For an equation that has a variable, a solution of the equation is a value of the variable that makes the equation true. So when we think about an equation, two expressions are equal, something as simple as this, 2 plus 2, that's one part of the equation, and the other part would be 4. Okay, so we can see that the value of 2 and 2 is equal to 4, and also 4 is equal to 2 plus 2. So when we talk about two expressions are equal, this is what we're talking about here. So we can see a couple of these examples here, whether it's numerical, words, algebraic. So we can see a numerical expression is 5 plus 4. Okay, we can see an expression represents one single value. So that's 5 and 4 there. I'm sorry, 5 there. Okay, an equation represents a relationship between two values. So we have 5 plus 4, just like I showed you up top equals 9. Okay, in order for an equation to be true, think about it, the left side must equal the right side. If the left side does not equal the right side, that means the equation is not true. In other words, if I said 5 plus 4 equals 10, that would not be correct. Okay, think about a balancing scale. The left side must have the same weight as the right side in order for it to balance. Same thing with an equation. So when we're thinking about expressions in word form, we could say something like a number plus 4. We looked at this in Module 10. And as far as an equation, a number plus 4 is 9. So one thing that we've talked a little bit about the word is a word that represents the equal sign. So in other words, if I'm looking at this equation, 2 plus 2 is 4. So we can see that is can represent the equal sign there. As far as an algebraic expression, remember, in order for it to be an algebraic expression, it must contain a variable. All right, so now we have n plus 4. And then for this, n plus 4 equals 9. So even though we don't know the value of n, this still is an equation there. Okay, remember it represents a relationship between two values. So we have n and 4, and then also 9. Now what we're going to be looking at today is we're going to be looking at a possible solution, okay, for these variables. So in other words, for an equation that has a variable, a solution of the equation is a value of the variable that makes the equation true. So for example, if I'm looking at n plus 4 equals 9, I need to find the solution for n. We don't have the book telling us anymore what the value of n is, so we had to come up with our own solution. Now what we can do is we can plug in a number. So 5, so let's say n equals 5. 5 plus 4 equals 9. So 5 would be a solution to this problem. Okay, in other words, it would solve this problem, so it would be the solution. So that gives you a little bit of background on what we're going to be talking about today. So let's look at numbers 1 through 4 on page 298, and I want you to work through this with me. So it's saying here, determine whether the value is a solution of the equation. So what we're doing for this is we have the equation 11 equals n plus 6. Okay, now even though this seems a little backwards, we're used to seeing the equal sign on the right. That's okay. All right. Even if you want to reorder it, that's completely fine. If you want to do n plus 6 equals 11, no problem at all. Okay, I know we're not used to seeing the equal sign. I'm sorry, the answer to a problem on the left, but that's algebra for you. Okay, so what we have here, we're trying to figure out if 5 would be the solution. Okay, in other words, if we plug in 5 for n, would that 5 plus 6 equal 11? And we could easily see that if we add 5 here, add it to 6, that does give us 11. So yes, number 1, 5 would be the solution for the equation. Now let's take a look at number 2. So we have y minus 6 equals 24. Now they're saying, would 18 be a solution to this equation? So what we need to do, we need to plug in 18 for y. So 18 minus 6, we know that gives us 12. So 18 would not be a solution for number 2. So for this, we would just write no. Why do we know it's not a solution? Because 18 minus 6 does not equal 24. All right, so we know that would not work. A solution, what could be a solution, or what is a solution? 30 would be the solution. 30 minus 6 does equal 24. But they didn't give that option to us, so we just simply write no. Next one. Remember, whenever we look at a fraction like this, that means division. And the numerator is the dividend. The denominator is the divisor. Okay, so that's important to understand with this. So what they have for us here is x divided by 9 equals 4. And they're saying a possible solution would be plugging 36 in for x. So let's take a look at this. 36 divided by 9, and you can even work this out on your calculator. Does that give you 4? And yes, it does. So that means that 36 would be the solution to this algebraic expression. In other words, we can replace the variable with the number 36. Now the last one we're going to look at, let's look at number 4. Remember, whenever there's a number next to a variable, that means a multiplication. So they're saying 15 times t equals 100. Now, they're saying t, would that be a solution for this equation? And what we could just simply do is 15 times 6. We know that gives us 90, not quite 100. Okay, so 6 would not be a solution to this problem here. So we would just simply write no. So you can see in this lesson, they're actually giving us a possible solution. It's not necessarily the correct solution. All right, but this is building into the next couple lessons where we're actually going to have to find what n would equal without them even suggesting anything to us. Okay, but this is just, again, building the foundation for the next lesson here. Now, the other thing we're going to do is take a look at a real world situation, and we're going to write an algebraic expression to represent it. Okay, so we're going to write an equation to represent each situation. So we can see this on the bottom of page 298, and I want you to work through this problem with me. Okay, so this says Maryland has a fish tank that contains 38 fish. There are 9 goldfish and F other fish. All right, so using the variable F there. All right, so with these problems, what we need to do, we need to figure out the parts of the equation. We need to figure out whether it's going to be addition, subtraction, multiplication, or division. Okay, now we know that the total amount here is 38. Why do we know the total amount, or why would we know that the the answer to this solution would be 38 because we know that the total amount of fish is 38. Okay, so we could just simply write 38 here. I'm just going to write an equal sign there. Now we need to figure out my expression. I'm sorry, the left side of my equation. So it says there are 9 goldfish and the variable f other fish. Okay, so what we have here is we're combining these two. Okay, because when you have the word and, so 9 goldfish and a certain amount of other fish, we know the whole part contains 38. We can see that that would be an addition problem there. So 9 plus f, or you can even do f plus 9, is going to give us 38. Okay, so the equation that would represent this situation, I know I kind of have them spaced out a little bit there, but that's okay. 9, because we have 9 goldfish, plus the variable f equals 38. Now, why are they using the variable f? Just to stand for fish. If you didn't have the letter f in there, you could use x or t or q or a, whatever you would like, would be completely fine. Now let's take a look at number 6 here. It says Juanita has 102 beads to make N necklaces, and each necklace will have 17 beads. Okay, so basically what we're trying to figure out the value of N there, okay? But really we're just trying to write this this real world situation as an equation here. So we know 102 is the total there. Okay, that's how many total that she has. Now, basically with this, we don't know how many necklaces she's going to make, but we know that each necklace will have 17 beads. So what we could see here is we have 17n equals 102. Okay, so n would represent the number that we don't quite know. Okay, in other words, how many necklaces can she actually make? Okay, she has 102 beads. Each necklace has 17 beads. Okay, how many necklaces can she actually make? So that's the algebraic expression that would represent this situation. Okay, now let's say, for example, what a solution would be to this. A solution would be n equals 6. Why would n equals 6 be a solution? Because I know that 17 times 6 would be 102. So 6 would be a solution to this problem. In other words, we could plug that number in for the variable, and that would give us our balanced equation there. Number 7, it says Craig is C years old. His 12-year-old sister Caitlin is 3 years younger than Craig. So basically we're trying to figure out how old Craig actually is. Okay, so we know his sister is 12 years old. All right, and we know that Caitlin is 3 years younger than Craig. Okay, so whenever we're trying to figure out how old somebody is and somebody else is 3 years younger, what we do is we take the age of Craig, for example, subtract 3, and that would give you 12 there. So C minus 3 equals 12. Okay, so I think I said it was his younger sister, but it was just his 12-year-old sister is 3 years younger than Craig. So again, we take Craig's age, we subtract 3 from it, and we get 12 that we already know about for Caitlin. We already know she's 12. We already know that Caitlin is 3 years younger as well. So C minus 3 equals 12. What would be a solution to that? We would need to think about what number minus 3 would give us 12. And so let's say 16, for example. 16 would not be a solution because 16 minus 3 actually gives you 13. However, a solution would be 15 because I know 15 minus 3 equals 12. It's as simple as just plugging in a number and then working through the problem and making sure it matches up there. Now the final one, number 8, it says Kim rented skates for H hours. The rental fee was $2 per hour, and she paid a total of $8. So we don't know how many hours that she rented skates for. Okay, so what we could see for this problem, we know she paid $2 per hour. We know she rented them for a certain amount of hours, and we know the total was $8. So we could just simply have 2 times H equals 8 to represent this situation. Again, it's important to understand what values you already know. We already know $8. We already know $2. Where do those fall in this equation? Okay, would not necessarily equal 2. Okay, but we know the total. Think about the total usually is always going to be the answer. Okay, so for example, she has a total of 102 beads. That was the answer. Total of 38 fish. That was the answer. Okay, so we can see 3 out of the 4 tells us a total, and that's where you put on the right side of the equal sign there. Okay, so we have the equation 2 times H equals 8. Now, if I'm trying to figure out a solution to this equation, let's say somebody says, oh, the solution is 3. What I would do is just work this out. 2 times 3 equals not 8, so 3 would not be a solution. That would not work. Okay, if I were to say 4 is a solution, 2 times 4 equals $8. That would be a solution. What would it be a solution to? For how many hours that Kim was skating? Seems like a lot of hours, but I'm sure she was up for it. Okay, so that finishes the video on lesson 11.1, writing equations to represent situations. Just remember, a solution to an equation means that when you plug in that number for the equation, it's going to represent a true equation. Okay, so make sure you understand that. If you have any questions about this concept, please come and see me.